We ran out of time in class on Monday to discuss some pretty important, but ultimately not all that difficult problems related to externalities in the economy. And the basic problem of externalities is that if it's a negative externality, there are costs that are falling on people outside the market, and the agents in the market aren't thinking about those costs, and so end up doing too much of whatever the market is doing. In the presence of a positive externality, there's a benefit outside the market that market agents aren't thinking about, and so they don't do enough. But the mechanics of how we illustrate this with basic supply and demand analysis are important to understand and give us a launching point to discuss trade-offs as we consider policy interventions to do something about negative and positive externalities, because the market fails in these situations to bring about the socially best outcome, as we will see. So what do we do? Well, it's ultimately a supply and demand problem, and a lot of the analysis is the same as what we've done in supply and demand analysis. So here, I've got orange as my pen color left over from whatever I did last time. Well, let me change that. Start with black. Our supply and demand, just as the market outcome, the demand curve that market participants will generate as they consider their valuations of goods is called the marginal private value function. In this example of a negative externality, there are no positive externalities, so marginal social value is simply equal to the marginal private value. The marginal social value function is always the marginal private value function plus the marginal external value function. People in the market and people outside the market. Anyway, this relationship is given by, well, let's just write it in terms of P. P equals 1,000 minus Q. Pretty easy function to work with. On the supply side is where supply comes from marginal private costs, and that function is given as P equals 0.75 Q. But there's this externality, and that is equal to marginal external cost equals 0.25 Q. Well, all that means is that our marginal social cost function is the sum of the marginal private cost function and the marginal external cost, and that gets us to the function P is equal to Q. That's our marginal social cost function. All right, so let's work through what the problem asks us to. What's the private market outcome? Well, we've been doing this for a long time, so this part of the problem should not pose any great difficulty to us. We set, the equilibrium condition is that quantity demanded and quantity supplied are equal. That means, had I had superscripts here indicating demand and supply, those quantity demand and quantity supplied are the same, and the price is the same, so we can just solve by setting 1,000 minus Q equals 0.75 Q. And we solve that to get, we add Q to both sides, and we get 1.75 Q is equal to 1,000. In other words, Q is equal to 1,000 divided by 1.75, which my handy-dandy calculator tells me is 571.43 marching band performances per year. Then we can plug that into either function. Either function's pretty easy to manipulate. Price is $428.57 if you want to hire a marching band for a party. Now, socially best, we're just looking for a quantity here. Although when I analyze the welfare, I'm going to have to assume a policy regime because our welfare analysis would depend on which policy regime we adopted. Anyway, the socially best outcome is always where marginal social value equal marginal social cost. So plugging information from the marginal social value and marginal social cost function, we get 1,000 minus Q equals Q. So 2Q equals, 1,000. Q equals 500. So the market, as we know, in the presence of a negative externality, the market oversupplies marching band performances to the tune of 71.43 marching band performances a year. So, pretty basic stuff, I hope, at this point in the semester for all of you. Let's move on to the graphical analysis. I've done this already, and make sure you could do it yourself. But here I've got my marginal private cost function. P is equal to 0.75 Q. P just equal to Q. That's my marginal social cost function. I've got that map there. 1,000 minus Q. There it is. Private market outcome happens at the intersection of the marginal private value, marginal private cost function. Socially best would happen at the intersection of the marginal social value function, marginal social cost function. There we have it. Matches the algebra quite clearly. The one thing to point out, usually I've given you problems where I have a constant tax or a constant, oftentimes I'll give you an externality problem, actually the next one, where there's just some constant externality. Here, the more marching band performances are offered, the larger the external cost. People just get increasingly annoyed with the marching band music, the more frequent this disruption is. All right, so there we have it. Notice I've labeled each area in this graph, and I'm going to have the tabulated welfare analysis, but the bottom line is we end up calculating the external cost as the total area underneath the marginal social cost function and the marginal private cost function. So this area between those two graphs, remember the vertical distance is the marginal external cost. If we wanted to sum up that external cost over all the units produced, we'd have the area between the two curves. The other thing to point out, I just assumed the optimal tax is going to be the welfare policy intervention to get us, the welfare policy isn't quite the right word, but the regulatory policy that'll move us from the market outcome to the socially best. The correct size Pigouvian tax or pollution tax is always equal to the marginal social cost, is always equal to the marginal external cost at the optimum level. So a tax of this vertical distance, which remember is just equal to 0.25 Q, that's the optimal tax. And what that will do is it'll move this market. Remember how a tax works. The buyers pay this much, the sellers receive that much. The tax introduces this wedge between what buyers pay and what sellers receive and brings in this long rectangle worth of tax revenue. You'll want to go through this more carefully on your own, but I've tabulated the results, and if I did this somewhat quickly yesterday, but if you find any errors, let me know. But here I've just summed up areas of consumer surplus under the market, under the optimal tax, producer surplus, same deal. The externality, the pollution damage, gets much smaller as market output shrinks. Government revenue, that is peculiar to a Pigouvian tax, of course. And then I calculated total welfare, and you can add these up, and hopefully, if my accounting was accurate, these add to the same. Now, here you can either look at the difference in the totals or the totals of the differences, and you get the same answer. That's one way to check your work. I do want to go back to that picture to point out one thing about the improvement that can happen as a result of a Pigouvian tax, an optimal Pigouvian tax. Anyway, notice that in calculating total surplus, we're calculating the area below the marginal social cost curve, the marginal social value curve, and above the marginal social cost function. And notice that this area is social surplus once we include the externality costs, which, as we should, right? People outside the market are people too. And notice that this area E is also equal to the deadweight loss, because that's the excess of cost over benefit for each unit past this optimal that is produced. We add that all up, we get the reduction in total surplus that happens because this market failed.